Hey, good morning everyone. Welcome back to live stream session again with the team Axiom. Today's agenda is to discuss about the association rules and the implementation of Apriori algorithm for having an association rules. Whenever we are dealing with the e-commerce applications, the Apriori algorithm is a classic association rule mining technique. Is highly effective for market basket analysis, identifying frequently co-purchased products to drive cross-selling and recommendations. We need to implement Apriori algorithm. To understand it more clearly, e-commerce websites give us various recommendations. Means whenever you are selecting or picking any product to purchase, underneath you will find the recommendations that you can. Then means like e-commerce applications suggest some product list as per the correlations. For example, if one guy is picking a t-shirt, so obvious that it will give us the recommendations to go with the trousers, jeans, or any other related t-shirts, shirts, rather like this. Means by how this is happening in the background, how your application is going to give the recommendations to the clients related to the products. There is certain association rules. If one is picking up eggs to purchase, obviously there has to be recommendations of bread, there has to be the recommendations of the milk. Probably he will be picking that eggs for the reason of creating developing a breakfast, that sort of things. So your e-commerce applications has to be intellectual enough to give these all the recommendations, and to achieve that association rules for the market basket analysis, we need to implement a priori algorithm is recommended over there. So how a priori works in e-commerce? The goal is to discover rules like customers who bought something, right, also need to be buy the related things. The key concept works over there. One is called as support. That support means a frequency of item set. How much times, obviously, whenever a priori algorithm have to deal with the data set. So how many times a particular product get purchased, and at that moment how many consumers have shown the support for the related items. That terminology called as support. Confidence means whenever that particular product selects, most of the time, more than 70%, another related items have bought. And the lift means measures true correlations. Means meaningful rule over there. Means there is like, obviously, if this is going to buy, that related thing is comes in the have been picked sort of. So on the basis of this theory of support, confidence, and lift, association rules work. So by the implementation of association rules on the data set of e-commerce consumers, support, confidence, and lifts can be evaluated and computed. On the basis of that, the association rules for the products can be generated, and by using that, it provides the recommendation to the various users, and that related recommendations will give the more choice for purchase to the consumer. And this is what exactly mean by the a priori algorithm for the implementations for e-commerce applications. Let us discuss in depth how it works, how to implement, what are its benefits with the team Axiom. Team Axiom is going to give us the all idea about the algorithm, the purpose, how it is going to implement, and what kind of benefits we will get by implementing it. Over to Team Axiom.
Good morning, everyone. Today I'm going to talk about association rule mining and the a priori algorithm, two essential concepts in data mining and analytics. Association rule mining is a method used to discover interesting relationships or patterns among atoms in a large data set. It helps answer questions like what items are frequently bought together or what web pages are often visited in the same session. This technique is widely used in the market basket analysis, e commerce, and recommendation systems, where understanding the connection between items can significantly impact customer satisfaction and sales. Among the various algorithms available for mining association rules, a priori is one of the most widely used due to its simple logic and strong theoretical foundation. It uncovers frequent item combinations which businesses can use to make data driven decisions, such as how to place products or what to recommend to users. Let's begin with the basics. What is association rule? An association rule is a way of expressing how atoms or events are related. It is simple if then relationship. Like if a customer buys bread, they also buys butter. The a priori algorithm helps discover these rules by identifying frequent atom combinations in dataset. It is a built on a powerful concept in data mining that if a group of atoms is frequent, then all of its subset must also be frequent. For example, if customers often buy bread, butter, and jam together, then they must also often buy just bread and butter or butter and jam. Smaller combinations of those items. These rules are usually written as if A then B, meaning if A happens, then B is likely to happen too. This kind of pattern recognition is invaluable in many industries from retail to healthcare. Now, let's see what is a priori algorithm. The a priori algorithm is an efficient method used to generate association rules. It does this by identifying frequent item sets or groups of items that often appear together in a transactional data set. The foundation of this algorithm is the a priori property, which states that all subsets of a frequent item set must also be frequent. This means the algorithm can safely ignore any item sets that contain an infrequent subset, thus saving time and resources. A priori works in a step-by-step manner, examining atom combinations from small to large and filtering out those that don't meet certain criteria. It also uses three main metrics to evaluate the quality of rules. First one is support. How frequently an item set appears in the data set. The second one is confidence. How likely it is that B is bought when A is bought. The last one is lift. How much more likely B is bought when A is bought compared to the general probability of buying B. So, why should we use a priori? First, it helps businesses understand customer buying behavior by analyzing purchase history. It enables cross selling, suggesting complementary products at checkout, which can boost sales. It improves inventory management and product placement by identifying frequently bought together items. A priori powers recommendation system in platforms like Amazon, Netflix, suggesting what to watch or buy next based on users' behavior. Ultimately, it enhances customer satisfaction and drive revenue through smarter analytics. Let me walk you through how the a priori algorithm works. Set minimum threshold. You begin by defining that count as frequent using minimum support and confidence value. Scan the data set. The algorithm identifies all items and combinations that meet the support threshold. Generate frequent item set. Only those item set that appear often enough in the dataset are kept. Create strong rules. From those frequent item set, the algorithm generates association rules that also meet the confidence threshold. This process continues iteratively, gradually increasing the number of items in each combination. Now that we have seen about the association rule and a priori algorithm, it's time to explore the other side. My team member will take you through the challenges, advantages, disadvantages, key concept and more. Stay tuned.
Thanks. Let's dive into the challenges and see if association rule and a priori algorithm is as flawless as it seems. Where can you use association rule and a priori algorithm? Practically everywhere. Association rule mining and a priori in particular is applied in many real world domains. Retail for market basket analysis to find which items are frequently brought together. E-commerce to build recommendation engines that increases customer engagement. Fraud detection to identify unusual patterns in financial transactions. Web analytics to understand how users navigate through websites, helping optimize site layout and content flow. Its versatility make it a powerful tool for turning raw data into actionable business strategies. To understand a priori better, let's look at the key concept. Support measure how often an item or item set appear in the dataset. Confidence measure how often the rule holds true. Live tell us whether the occurrence of one item improves the likelihood of another. Purning is used to eliminate unpromising item sets early in the process. It follows a level-wise iterative process that adds one item at a time to build larger item sets. Candidate generation helps explore all possible combinations. The downward closure property ensures that the algorithm doesn't waste time on combination that includes infrequent subsets. Despite its usefulness, the a priori algorithm comes with challenges. It has high time and space complexity, especially as the size of the dataset grows. With large datasets, the number of potential items became overwhelming. It often generates too many rules, many of which are redundant or not actionable. It requires fine tuning of support and confidence threshold to avoid missing important patterns or generating too many unhelpful ones. So, while it's powerful, it must be used carefully. Let's now look at the advantages of a priori. It's easy to understand and implement, even for beginners in data mining. It uncovers hidden patterns that are not immediately obvious, helps make data-driven business decisions, improving strategies based on real behavior, works well on structured data sets, especially transactional data like invoices, shopping history, or logs. Its simplicity makes it a great starting point for anyone exploring association rules. But there are also some disadvantages to consider. It's not efficient for very large or sparse datasets where meaningful items combination are rare. It can produce redundant or obvious rules requiring post-processing. Manual turning of support and confidence value is needed to balance rule quality and quantity. The computational cost increases rapidly with the number of items and transactions, and it may generate a huge number of rules, making interpretation difficult without good filtering technique. These limitations can be managed, but they should be kept in mind when choosing a priori. The a priori algorithm is a widely used and powerful method for discovering meaningful patterns in data. It's especially valuable in retail and e-commerce, where understanding association between items can lead to a better customer experience and increased revenue. It helps enhance market basket analysis, power recommendation system, and support smarter decision making in inventory and customer relationship management. When used thoughtfully with proper threshold and rule filtering, a priori becomes a vital tool in any data analyst toolkit. Now that we have explored the theory and application of association rule, mining, and the a priori algorithm, it's time to see how it's actually work in practice. To walk us through the demonstration, I would like to hand it over to my teammate who will show us a real world example of how a priori is applied on a dataset to generate association rules. He will guide you through the steps from the data processing to generating frequent item sets and visualizing the final rules. So you can see exactly how the algorithm brings data to life. Over to you, my teammate.
So hello everyone. Today I'm going to demonstrate a priori algorithm and association rule mining in action. That how the things can be done from it. So let's take an example. You all have gone through some e-commerce website that you see that if you buy a cloth or some sort of things, then when you scroll down, it will suggest some associated items according to the product which you have explored or searched from the e-commerce. Now, in our case, that what we have to do is we have a drop-down list which contains some items as bread, butter, jam, milk, etc., etc. So, whenever a user click on the any of the item, it will suggest the associated item. As you can see that when we'll click on the milk, then it will suggest the associated item as bread and butter. So the idea behind this association rule is there are some mathematical terminologies such as support, confidence, lift, and transaction list. So now let's discuss these terminologies in brief. That what is support? So support is a ratio between some number of transactions which containing the item by the total number of transactions. So it indicates that how popular an item set is. Then confidence. So confidence is the ratio between number of transaction which contains both the items and by the number of transactions containing only first item. And uh, at last, lift. So lift is the ratio between confidence and support. So the idea behind this logic is I have created a code, and you can see that. So the major prerequisites are the folder structure, which is backend in the sense as I have created the backend logic as a priori module.py. In the front end, the main drop down list. So this is the uh, a priori module.py file. So in this source code, you can see that I have imported some libraries such as ML frequent patterns, and pandas. So same as we need some more libraries to execute this code. So we need as the Flask course. And the a priori module, which you can see here in the app.py file, is this file which I have called here as a library. So you can see that in the run a priori function that I have passed some parameters as transactions, the number of item sets the user bought, and I have set some threshold value as minimum support is 0.5 and minimum confidence is zero point 0.6. So whenever the user will uh, bought the bought any of the product, then it will suggest uh, the associated items using this criteria as minimum support will be equals to 0.5 or greater than, or minimum confidence is 0.6 or greater than. So in this I have in this file I have imported all the libraries and call this file a priori module as a library, and import the function of run a priori. Then I pass some data set as grocery shop product as milk, bread, eggs, jam, butter, and now you can see that this is the drop down. So now let's talk how to execute it. The major question is this. So for executing it, we need to create a virtual environment as I have previously created the virtual environment. So for creating the virtual environment, we need to go to the terminal and pass the command as python space -m and virtual environment or virtual environment. So basically it create a virtual environments and in your folder structure. So I have previously created it. What I'm going to do is I'm activating the virtual environment. So we need to give the command as venv scripts and activate. As you can see that there's a batch file activate.bat. So it will activate the virtual environment. So as you can see that I've successfully we have executed the virtual environment. Now I'm going to do is I'm changing the directory which is backend and executing the app.py file. So it may take some time. As you can see that this we have successfully executed the query and Python app.py, and it will says that it running on 5000. So now I'm going to do is this is the HTML file. You can see that we have successfully uh, display the so whenever user click on the any of the product, then it will here you can see that the options or the results are getting reflected as 200 and get associated items and the methods get post and options like it. So the bread, the when we click on the bread, it will suggest the butter because the minimum support or minimum confidence is is zero point 0.5 and zero point 0.6. If the criteria will be matched from there is zero point 0.5 or zero point 0.6, then it will display the results. As I'm giving the as I'm selecting the milk, then it will suggested the items as bread and butter. And whenever I will click on the cola, then it will suggest that no items found because there's no criteria match, which is zero point 0.5 or zero point 0.6 is the minimum confidence or minimum support. So this is the demonstration of a priori algorithm. So that was an exciting demonstration. You just saw association rules mining and the a priori algorithm in action. Right before your eyes, and got a real sense of how powerful it is in uncovering meaningful patterns from data. So before we conclude, I am pleased to announce that our respected director, Mr. Sushil Purke sir, will now address your thoughts, and please feel free to share your thoughts about how association rules and a priori algorithms can be implemented in your scenarios. Over to you, sir.
Hey, thank you, Tanishq, and entire team Axiom. It was a wonderful job you did to elaborate about the association rules, how association rules is important in case of e-commerce applications. At the same time, to achieve that about the support, confidence, and lift. Okay, we need to apply a priori algorithms, and good demonstrations by using Python, how we can build that library and able to achieve we train that data sets to provide us that all the support, confidence, and then recommendations for the e-commerce applications over there. It was fabulous, and then I hope the audience who is attending these sessions will get a clear-cut idea how Apriori algorithm can be implemented to achieve that all the association rules in the e-commerce applications. Right. Thank you very much, guys, for attending these sessions. And at the same time, if you want to have some other recommendations of new technical stacks and the sessions, we will Team Exom will prepare that. Or at the same time, you can join us, and we can together able to explore, able to enhance the technical topics, right? And so that by enhancing our skills, we can able to serve the industry better. Thank you very much for having your associations for this live stream. You're welcome with your comments, and then at the same time, if you're in sessions there, reach out to us. Thank you very much, guys. Have a wonderful day ahead.
Thank you.
Thank you so much.